Welcome to the Math Record. Today we'll be covering the CCML Algebra 1 Contest 1 2017-2018 Division A. Okay, let's begin. Question 1. Evaluate 4 to the power of 5 plus 4 to the power of 5 and then add that 2 more times. Since this is Contest 1, usually we'll just use our calculator. So are these type of questions, I'll usually just use my calculator so I don't have to make any math mistakes or errors. So we just have 4 to the power of 5 and we get that as 1024. And then since there's 4 of them, you just multiply that by 4 because it's the same number. So your answer is 4096. Basically just that simple. Okay. Question 2. Determine the least common multiple of 120 and 168. As I said before, if you have a calculator, you could use it. I'm pretty sure for the TI-84 and the N-Spire, there are ways to just plug in both these numbers and then get the least common multiple. But if you want to do it with by hand, you just have to prime factorize both of them. So you have 120 and you have 168. 120 is 2 and 60. We'll divide it by 2. 2 times 60 is 120. So you just prime factorize this. Divide by 4, and that's 15. So we get 2, 2. Sorry, that's a little close. And that's 3 and 5. Okay. 168, you can divide that by 8, so this gets 21. This is just 2 to the power of 3. And write it a little neater, okay? And this is just 3 times 7. So on this side, we have 2 times 2 times 2 times 3 times 5. The least common multiple is just having all these factors. So we have 2, 2, 2. So we have the highest number of 2's we could get is 2 to the 3. But they have the same amount, so it's fine. So 2 to the 3 times. We need 1, 3. We need 1, 5. And we need 1, 7. So using your calculator, we have 2 times 2 times 2 times 3 times 5 times 7. Which gets you an answer of 840. Okay. Question 3. Evaluate 30 divided by 3 parentheses 2 plus 3. So it's 30 divided by 3 and then times, and then 2 plus 3 is 5. Right? So which one do we do first? It's always reading from left to right. So 30 divided by 10, 30 divided by 3 is 10. 10 times 5 is equal to 50. So your answer for number 3 is 50. First 3 questions are pretty simple so far. Okay, number 4. Evaluate 7 plus 3 over 7 plus 5. Leave your answer as a common fraction. So 7 plus 3 is 10. 7 plus 5 is 12. So you gotta leave this into common fractions. So you divide the top and the bottom by 2. So 10 divided by 2 is 5. 6 divided by 2 is 6. 12 divided by 2 is 6. So your answer left in the simplest form is 5 over 6. Okay. Number 5. Mr. E's classroom has 32 students. The number of students that like Inspector Pora is the same as the number of students that like Mama Remoste. Sorry about that. 5 students like both Inspector Pira and Mama and her that name. 3 students like neither. How many students only liked that name? I'm not gonna say it again. We'll butcher it. So let's just make a Venn diagram. So we have Inspector Pera, which we'll just label as P, and the other name, which we'll just label with M. Okay. So there's 32 students, and it said right here that 3 like neither. So we have 3 outside. That means, and they said 5 students like both. So 5 is in the middle, right? And then they said the number of students like Inspector Pira is the same as the students like that other name. So is this circle is the same as this circle. I'm sorry if I couldn't retrace over it perfectly, but basically that's your general idea. Since the middle is the same for both of them, so there's 5 people, that means this side has to be the same as this side. So we'll just write this both as variable x. And we'll just solve it using like a variable. So x plus x is 2x. 5 plus 3 is 8. So that's the total amount of people. Our total amount is 32, so it's equal to 32. So 32 minus 8 is 24. So 2x is equal to 24. And 24 divided by 2 is 12. So how many students like only mama would be would be would just be x, which is 12. So the answer is just 12. Okay. Number 6, evaluate 1/3 times 2/4 times 3/5 times etc. until like 43 over 45 times 44 over 46. First, you want to see the pattern. Well, if you kind of just look at the numerator and the denominator, you kind of see that the denominator is always 2 more than the numerator. So you have 1 and then plus 2 is 3, right? And then you have 2 plus 2 is 4, and then 3 plus 2 is 5, right? So you have 1/3 times 2, 4 times 3, 5 times like 4, 6, right? And then etc., etc., etc. Until you reach like 43 over 45, and all the way until you reach like 44 over 46. Okay, so we see it goes from 1, 2, 3, 4 until 44, and 3, 4, 5, 6 all the way to 46, right? So how do we simplify this? Well, generally, if you kind of just write all this out, right? We have a 5, 6, 7, etc. We just cancel this one and this one, 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 right? So if we keep canceling out, we could infer that since this is going up to 46, right? There's gonna be a 45, 44. You could cancel out all those numbers in between. All those from 2 to 44 in the numerator can cancel out all the numbers from 3 to 44 in the denominator. Sorry, not the 2. We cancel out the 3 to 44 on the numerator from the 3 to 44 on the denominator. So all this to all this could cancel out until we're left with the 1 and 2 from the beginning. 1 times 2. And then on the bottom, we cancel out up to the 44, right? Because we end at the 44 here. That means we have a 45 and a 46 left. 45 times 46. So you could use your calculator. 2 divided by 45 divided by 46 is equal to 1 over 1035. So that is our answer for number 6. Okay. Sorry. And number 7. One leg of a right triangle has length 12 over 7. And the length of the hypotenuse is 20 over 7. Determine the number of square units in the area of the triangle. Leave your answer as a common fraction, okay? So usually for geometry questions, you could just always draw a picture of a right triangle. Since it's right triangle, we have a right triangle here. And we have one of the legs is 12 over 7, so it doesn't matter, just choose a length. So let's just choose this one. And then the other for hypotenuse is 20 over 7. So you could use the Pythagorean theorem, which is, let's just label this x, which is just x squared plus 12 over 7, the other side length squared, right, is equal to the hypotenuse squared. So you get 20 divided by 7 squared, and then 12 divided by 7 squared, and then you subtract those two together, and then you square root it, and you get 16 over 7, right, as your x. Okay, so x is equal to 16 over 7. Another thing you could do is that usually for the CCML, they kind of choose numbers that are Pythagorean triples. So it might not seem like it because it looks like it has these improper fractions. But if you kind of just divide the common multiple from the numerator, you kind of see a pattern. So you kind of divide 4 out of the 20, you get 5 out of 7. And you kind of divide 4 out of the 12 is 3 out of 7, right? So if you kind of think about it, you could just ignore the 7s since they're the same thing. You have a 5 and a 3. Doesn't this look familiar? That looks like the 3, 4, 5 triangle, right? So we just need to scale it up by the same amount. So if this is the 3, 4, 5 triangle, This is the 3, this is the 5, and this is the 4, right? This 5 is just multiplied by 4 over 7. This is just multiplied by 4 over 7. So this side has to be multiplied by 4 over 7, right? So this is 20 over 7, this is 12 over 7. So this is 4 times 4 is 16 over 7, which gets the same number. So usually a quicker way if you don't want to use your calculator to like spend time on it. But that's not the answer. The answer is asking for the area. So the area is just 12 over 7 times 16 over 7 times 1/2. You multiply by half because it's a triangle. Then you just use your calculator for this so you don't make any math mistakes. So 12 times 16 divided by 2 is 96. 7 times 7 is 49. So your answer is 96 over 49. Basically just that simple. Okay, number 8. In the 6-digit number 3,400 300,000 for 340,000 A 280 B. So A represents an unknown digit in the thousands place, makes sense. 8 is in the tens place, and B is in the units place. How many different numbers are possible such that the 6-digit integer 34A28 B is divisible by 8? So we have 34A 28B is divisible by 8. So how do we solve this? Well, generally, you could just split this up into parts. So you have the 3, right? That's the same thing as saying this, right? So we have 300,000. So 300,000 divided by 8 is an integer. So we kind of don't have to focus on this. So that's what we do for every single number. So this is so if you kind of add them all up, right? So now you have 40,008, and you can just have a 40,000 divided by 8 is 5,000. So that's an integer, so we don't have to worry about that. So now we have plus. This is in the thousands place, right? So you have to multiply this by 1,000. So why do we do that? Because like let's say A is equal to 1, right? So it's 341,000. So you put a 1 here. A is 1, so you have 1,000, right? Because you have 341,000, right? So you have just this. Now you divide that by 8. So 1,000 divided by 8, because they're both just numbers, so you just divide them out. You get 125A. Since this is an integer, and only integers could be plugged into A, that means this entire thing has to be integer. So we don't have to worry about this. Okay? Now let's do the 200. So it's 200 divided by 8. So 200 divided by 8 is equal to 25, which is an integer. So we don't have to worry about this. Now we have 8, which is in the tens place, so it's 80 divided by 8, which is obviously an integer, which is 10. So that's gonna be an integer, so we don't have to worry about it. Now we just have b divided by 8, right? So based on this idea, which is just 340,280b, right? Which you can split into parts, you can find out that this is integer, this is integer, this will be always an integer. So any number that you substitute with a will always be an integer. So since the numbers we can substitute for a for like a base 10, it's just 0 to 9, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 possible combinations for this one. For A. Now we just need to find out how many combinations we could put for B. Right? So we know 200, the 2 here is divisible by 8, so we don't have to worry about it. 8 divided by 8 is obviously an integer, so we don't have to worry about it. Now we have B and 8. So for the 6-digit number to be divisible by 8, that means this number, that means B has to be divisible by 8. Because everything else is going to be an integer. So you add integer plus integer plus integer plus integer plus integer plus the last integer, right? It's just going to be an integer, right? So we just need to find an integer. So B could be 0 or 8, right? Because those are the only integers. So 0 divided by 8 is just 0, so that's an integer. 8 divided by 8 is 1, which is also an integer. There's no other numbers. So B can have 2 possibilities, 0 or 8. So we have 10 possibilities for A and 2 possibilities for B, so you just multiply them. So you have 20 possibilities. So your answer is 20. So the reason we multiply is that you could just have 0 0, 1, 0, 2, 0, 3, 0, 4, 0, all the way up to 9, 0. And then you could just have 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, all the way to 9, 8. So since there's 10 here and there's 2 here, that means each of those 10 could be in each of those 2. So that's a total of 20. So your answer for number 8 is just 20. Okay. Number 9. Find the prime factorization of 227,766. So as I said before, usually your calculator could have has these functions that are able to just do these. Like I know for sure that Nspire has a way that you could just go to numbers, go to your calculator, go to numbers, and then you just like factor it. I think the TI-84 also does the same thing. So, but if you want to like do this by hand, you could just you recognize that since 6 is even, you could just divide by 6 out first. So you have 227,766. I would usually use the calculator way just so that you make a mistake, but if you want to do it by hand, you just do this. So you have 227766 divided by 2, right? And then you could use your calculator to get the other number, which is 113883. Okay, so from here we know that 3 is not even. The units place 3 is not even, so we have to choose an odd number. Let's start with 3 because that's the lowest odd. It's aside from 1. But you're basically just going to be dividing by primes. That's why it's called prime factorization. So divide by 3. Okay, it's divisible by 3. It's 3 and 37961. Okay, let's see if this number is divisible by 3, which is not. Okay, so let's try the next number. So it's not divisible by 5 because 5 usually ends in 0 or 1, right? Because you have 5, 10, 15, 20. So it ends at 0 or 5. And this ends at 1, so it's not going to be divisible by 5. So the next prime is 7, so just divide by 7. Okay, that worked. Which gets us 5. Gets us, we have 7 and 5, 4, 2, 3. So the next prime is 11, so let's try 11. So we have 2 times 3 times 7 times 11 times 493. Sorry, I'm just kind of running out of space. So 493, is that divisible by 11? That is not. Is it divisible by 13? Is not. Is it divisible by 7? It is not. So 493 divisible by 17. Okay, 17 works. So we have 2 times 2 times 3 times 7 times 11 times 17 times 29. So that's our answer. 2 times 3 times 7 times 11 times 17 times 29. So that's the prime factorization of 227,766. Okay, so far these questions are pretty simple so far. Usually if you just use your calculator, you should be fine. So number 10, what's the least common multiple of 20, 24, and 90? Well, we would just do the same process as we did for number 2, but now we're gonna do it for 3 numbers. So we have 20, we have 24, and we have 90. So 20 is the same thing as just 4 times 5, so 4 is just 2 times 2. So 20 is just 2 times 2 times 5. 24 is just 8 times 3, so that's just 2 times 2 times 2 times 3, right? So 4, 8, 24. Okay. 90 is just 9 times 10, so 9 is 3 times 3, 10 is 2 times 5. So the least common multiple is going to be the all the numbers that are combined. So how many 2's do we have? We have 2 2's, 3 2's, and 1 2, right? So we're going to have to need, so the highest amount of 2's that we need is 2 to 3. Now, do we need any 3's? Yes, we need 1 3 here. There's 0 3's here, 1 3's here, and 2 3's here. So we need 2 3's because that's the highest amount. So we need any 5's? Yes, we need a 5. We need 1 5. There's 1 5 here, no 5's here, 1 5 here, so that's 5. So we could always check to see if it works. There's only 2 2's and 2 5. That works. 2 to 3. Yes, that's work. And the 3. Yes. So 3 to 2 and 2 and 5. Okay. So this works out. So we have 2 times 2 times 2 times 3 times 3 times 5. And we get an answer of 360. So the least common multiple of 20, 24, and 90 is 360. Okay. Question 11. Evaluate 1 plus 4 plus 7 plus 10 plus etc. until plus 85 plus 88 plus 91. So when I see this, it's usually going to be a sequence. So since it's a sequence, that means either it's going to be geometric or it's going to be arithmetic. How do I tell the difference? Geometric is going to be multiplying or dividing. Arithmetic is plus or minus. So since this is a plus, that means I know it's arithmetic. So and then another, but that's only one of the conditions. Then other conditions that you gotta check is if the difference is the same, right? So 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3, 88 minus 85 is 3, 91 minus 80 is 3. You don't have to check all the terms, but I'm just saying that they're all like a difference of 3, so it is an arithmetic sequence. So easy way to do this instead of just adding every single number by hand is that you just the formula to find the sum of a sequence is basically the number of terms, right? Divided by 2 times the first term plus the last term. That's the formula for the sum of arithmetic sequence. If it's finite, so it means like it ends somewhere. So it ends at 91. So it doesn't go like to like infinity. So how do we know how many? The first term is 1. The last term is 91. So the only thing we need to find is the number of terms. So since I know that it starts at 1 and it goes by a common difference of 3, that means it must follow the equation 3x plus 1, right? So if you plug in 0, it's 1. If you plug in 1, that's 4. If you plug in 2 for x, right, that's 7. Right? So if you follow this formula. So this formula checks out. So when does this number equals 91? So minus 1, 90, divided by 3 is 30, right? So there's 30, but we start at 0, right? So it's 0, we get 1, so we start at 1, and then we end at 91. So if x could go from 0, and we end at x equals 30, that means we have 31 terms, right? Because it's 1, 2, 3, 4, 5, 6, 7, 8, until etc. until 30, so that's 30 numbers. But you gotta include that 0, so that's 31. So there's actually 31 numbers. So using this idea, we know that the number of terms is 31. So it's just 31 divided by 2 all over the first, 31 divided by 2 times 1, which is our first term, plus our last term is 91. So using our calculator, 91 plus 1 times 31 divided by 2, you get an answer of 1,426. So this is just a simple arithmetic sequence question. Another way you could do it is that usually I use my calculator. Mostly, if this counts as 1, I'm just going to use my calculator. So if you have your calculator, I don't know how for the 84, but for the Nspire, this calculator, the Nspire, this calculator, you could just go to basically the calculus section, and then you could find out there's something called sum, and then you could just use a Euler summation. So you have a Euler summation from x is equal to like 0 to x equals 30 of 3x plus 1, right? This is the equation that we got. So it plugs in from x equals 0, x equals 1, x equals 2, x equals 3, all the way to x is equal to 30, which stops then, right? So you could just make this equation and it will just solve it for you, which should give you the exact same answer. So if you don't want to do the math and you want to make sure that you're right, usually this is the way. Number 12, or you could just do it by hand. It's fine either way. Number 12, determine the length of a shorter side of a rectangle that has an area of 48 and a perimeter of 67. Right? So if it's a geometry question, just draw a picture. So let's say we have x and y. That's our two sides. Since it's a rectangle, that means this is y and this is x. But since it's a rectangle, we don't really need to label it. So they said our area is 48 and our perimeter is 67, okay? So we know that x times y is equal to 48 because that's the area. And we know the perimeter is just x plus y plus this x plus this y, which is just 2x plus y is equal to, because there's 2 of each, and then you get a perimeter of 67, right? So we know this is true. So usually when I have this, I don't like to plug in like I know it seems simple to like just say y is equal to 48 over x, or say x is equal to 48 over y, and then you just plug into here. Usually I don't like to do that. It's just not convenient because then you could have like 48 over x plus this, and then you kind of get like x squared plus 48 over x, and it kind of gets a little bit messy. So it's a little strange, but it's gonna do the same thing. I just usually prefer the method where I just have this number, uh, have the linear number go into like the product number. So usually I have the 67 divided by 2, and then you're going to minus the x, which is equal to the y, right? So you just plug it into this equation. So we have negative x squared plus 67 over 2x, right? You just plug in y to x, and you just multiply the x to the negative x, and then 67 over 2 to get this. It's equal to 48. So we have this. Sorry if it's kind of bent, so... Okay, let's just rewrite this in the top with that new equation. So we get negative x squared plus 67 all over 2x. And then that was equal to 48, right? So you have to minus that 48. So then you get 0 on both sides. Now, usually what I do is that I like to get all the decimals out, and I want to get this term positive. So I'm just going to multiply this entire thing by negative 2. So this will get 2x squared, right? And then minus 67x, and this is plus 96 now, which equals 0. So what you could do is that you could just factor this by using the quadratic formula, or just basically like using any method you want. So when you kind of factor this out, you're going to get 2x and x, I'm assuming. So since this is even and this is even, I know that since this is positive and this is negative, I know both of these have to be negative. So this is going to be even, so this is going to be even. So this multiplied to like this number here, it's going to be even regardless. So since this is odd, that means this has to be the odd number. So it would kind of factor out 96. We kind of get like 2 to the 5 minus 3. 2 to the 5 times 3, right? So since you need an odd, the only odd is 3. So we had to put the 3 here. So the other thing is 2 to the power 5, which is 32. Oops, sorry about that. These are kind of close. So minus 3 plus 30, minus 32. Right, so that's plus 96, which gets this. Let's see if it gets the middle term. So 32 times 2 is 64, negative 64, and then plus negative 3 is negative 67. Okay, so this entire thing works. So x is equal to 32, and x is equal to 1.5. So how do we know which one to use? Usually for these type of questions, when they're asking for rectangles, usually both of them work. It just kind of depends on which one you want to put. So x could be either 32 or 1.5, and then the y would be the other number. So if x is 32, y will be 1.5. If x is 1.5, y will be 32, which kind of makes out, right? So if you kind of multiply 32 times 1.5, you get the area, right? Which is 48. And then you get 32 plus 1.5, and then multiply that by 2, which is 67, which is the perimeter. So it works out. So usually both of these numbers work. So it just determines which one you want to have as your length and which one you have as your width. So the question is asking for number 12, determine the length of the shorter side. The shorter side is the smaller length, so it's just the 1.5. Your answer is 1.5. Okay. Number 13, what is the smallest positive integer that has exactly 12 factors? Okay, for this type of question, you need to understand like how number of factors a term works. So let's give an idea. Let's say we have 30, right? So the trick is basically you're gonna factor this. So it's gonna be 3 times 10. 10 is just 2 times 5, right? So what you have is 3 to the power 1 times 2 to the power 1 times 5 to the power 1. So here's where the trick comes to find the amount. The number of factors that the 30 has is basically adding 1 to each exponent and then multiplying them. So 1 plus 1 is 2, 1 plus 1 is 2, 1 plus 1 is 2. So you multiply all those two together, and you get a factor of 8. So, right? So you have 8 factors. So do we know that's true? Okay, let's try factoring this out. We have 1 and 30, right? So 1 times 30 is 30. So this is usually the way I find out. I just write them in pairs. So then I have 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. Okay, since 5 and 6 are really close to each other, I know that it ends right there. So we have these, right, as our factors, which is 1, 2, 3, 4, 5, 6, 7, 8, which is true because we just got 8. So how do we know that our formula is correct, which is 3 to the power of 1 times, 2 times 3 times 5, and they're all to the power of 1. So how do I know that I have to add 1 to each and multiply them? Well, if you kind of think about it, it kind of seems like a combination question. So you either could have 0 2's, right? Sorry. You could either have 0 2's, 1 2, 0 3's, or 1 3, and then 0 5's or 1 5, right? If this was like 150, right? I just multiply this 5 to the 2. So you could just have 5 to the 2, right? So you have all these possible combinations. So you could just have this, you could have this one, this one, this one, or you could have this one, and this one, or this one, and this one, or like this one, and this one. You know? So you could just, you see that you're making combinations with these kind of numbers, right? So you have 2 possible here, 2 possible here, and 3 possible here. So that's going to be 12, right? So 150 is 12. So you kind of see that you have these really like easy ways to do it. So that's why we could just add 1 to each exponent, because then if 0 is 1, if you have 1 to the power of 1, right? That's got to be 2 because you have 0 and 1. So you can just, so based on like arithmetic, you could just add 1 to each exponent and then multiply them together and it's going to work out. And that's how like the formula is used usually. So when we have something that has the smallest possible integer that has 12 factors, right? So 12 factors, since we're multiplying numbers to exponents, right? That makes the 8. Now we have to do the same thing with 12. So 12 could be factored out as 1 and 12, and then 2 or 6, and then 3 and 4, right? So it ends here. Since we add 1 to each exponent and we multiply them together, right? We gotta have to find a way to like do this easier. So we could have, if you have subtract 1 from each exponent, so this is 0 and 11. You can't have 0, so this one does not work. You cannot have that. So even any number, even if it say it's like 56 factors, right? You have 1 and 56. You cannot have that because 1 minus 1 is 0. And you can't have 0 because then you have 3 to the power of 0, which doesn't make sense at all. So you can't have that. So to the power of 6, which is 1 and 5, 3 and 4, which is just 2 and 3, right? Minus 1 from each. And these are only for the doubles. If you want triples, right? 12 is just 2 times 2 times 3, right? So that's 4 and 12. So you subtract 1 from each of them, so it's 1, 1, and 2. So now we have these 3 combinations, 1, 5, 2, 3, and 1, 1, 2. So how do we find the smallest? Well, generally, when you kind of have to multiply numbers, right? So let's just use 1, 5 as an example, right? You have 1, 5. We don't want to choose something like 7 and 2, right? Because then it's got to be a big number. Because instead, we could just choose 2 and 7, which makes it even smaller, right? So usually for higher exponents, we're going to choose lower primes. And for lower primes, we're going to use higher exponents. Because we want to minimize the amount of times, like the amount of numbers that are going to be multiplied to this. Okay, so basically, if we have a 7 here, right? It's going to be multiplied less than if we're going to have a 7 here. This is going to be multiplied 5 times versus something 7 multiplied 1 time. So you have a 2 here and a 7 here versus a 7 here and a 2 here. It's going to be less because now you're multiplying the bigger number less times and the smaller numbers more times. So you get a smaller number overall. So when we have this, we just choose the smallest primes. So the 2 smallest primes is 2 and 3. So we just have 2 here, the smaller number, and the bigger number. Right? So this is our first one. Now 2 to 3. So this one is just 3 to the power 1 times 2 to the power of 5. So that's 2 to the power of 5 times 3, which equal to 96. So the smallest possible combination for 1, 5 is 96. Now for the smallest combination for 2 and 3. So 2 and 3. Bigger exponents uses smaller numbers, right? So this is 2 and this is 3. So it's 3 times 3 times 2 times 2 times 2, which is 72. Right? So this the smallest possible for 2 and 3 is 72. Now we have 1, 1, 2, right? So we have 1, 1, and 2. So the smaller number always go with the biggest exponent, so 2. Now the next smallest, since we have 3 numbers, that means we need 3 primes. So the 3 smallest primes is 2, 3, and 5. I use the smallest primes because we don't want like 2, 3, and 7, right? Because instead of 7, we use 5. So they're just smaller numbers, so we make a smaller number overall. So this is a 3 and that's a 5, right? So we could just multiply them together. So 2 times 2 times 3 times 5, which gets us 60. Do you kind of see the pattern of how this is working? If you kind of just choose numbers as close together. This is 2, 6 gets to 1, 5, and the 2, 3 gets from 3, 4, right? So technically, whatever number that's really, really close together, that's gonna usually be the smallest of the doubles. If you have a triple, that's gonna be even smaller. So that's gonna be 60. So your answer for number 13 is 60. So the first thing you do is just prime factorize it, and then you kind of subtract 1 from each of those possibilities, and then you basically just do them, just find the smallest primes and you just get them out. It's not really that hard, but you understand the trick is really simple. Question 14. Evaluate square root 6 plus square root 6 plus square root 6, etc. into infinity. So I don't have the packet, so I wrote this in a Google Doc. So what this actually was square root 6 plus square root 6 plus square root 6 plus, yeah, as it goes on, right? So this goes on for infinity. What you kind of do is that you kind of look for the pattern. So the first thing you do is that you denote this entire thing as x. So we call this entire thing as x. And we're going to solve it like a linear like question or quadratic. Usually it's quadratic. So what I mean is that you're going to have to look for this number inside this equation. So where does this thing repeat again, right? Where does this repeat in this? So if you kind of just look very carefully, you can see that it repeats right here, right? It looks exactly the same. Or it repeats right here. Usually, and then what you do is that you kind of just substitute that variable in. So you have square root 6, right? We said it looks like this, right? So then we just have plus x. Or you could just have plus square root 6, and then you see it right here, right? You have x. Usually I like to do it the first way because the closest answer is going to give you the simplest way to do it. So instead of having this, we just have this, which is much easier. So usually I just look for the first instance where the pattern repeats, and then I just do the math on it. So now we just have x is equal to square root 6 plus x. Now you just square root both sides, that's x squared. 6 plus x. Now you just get them all to one side, so you have x squared minus 6 is equal to 0. Now we factor this, x minus 3 and x plus 2, which is 0, right? So that's x squared plus 2 minus 3, so that's minus x, and then minus 6, so this goes out. So your answer is x is equal to negative 2 or x is equal to 3. So usually there's only one solution for this. To think of what answer is going to be is not going to be the negative. It's never going to be the negative because, right, if you just look at the question, you have a positive plus a positive plus a positive plus a positive plus a positive, right? So it's just going to be positive. So there's no way it's going to be a negative. It's 3. Another way to think about it is that since these are radicals, usually they're only going to give positive, and they're square roots. So they're going to have to be a positive. So it has to be this 3. So the answer for this is 3. A different way to do this is that if you have your calculator, and if it's calculator allowed, basically what you do is that you kind of just spam your calculator and you just put the square root 6 inside a square root 6 inside a square root 6 inside the square root 6. And then you just keep going. It's not going to give you the precise answer 3 unless you put it a bunch of times, but if you do it like a couple times, like you put in like 4 or 5 times, you kind of see a trend where it seems like it's like square root 6, which is like 2 point something, and then it goes to like 3, right? It goes like 2 point something to like 2.9 to 2.99 to 2.99999, right? It gets really, really close to 3, and you could just assume that since it's going infinite, it's just gonna keep adding like smaller numbers until it finally reaches that 3. But if you want to see how that works mathematically, the answer for 14 would be like 3, and that's how we did it. Number 15. Determine the sum of the squares of two numbers if the two numbers have a sum of 9 and a product of 12. Okay, so we have two numbers. Let's call it x and y. So the sum is x plus y. We have x plus y, so two numbers is 9. And the product is 12. So x times y is 12. And then they say they want us to find the sum of the squares. So it'll be x squared plus y squared. And we need to find that. We need to find this this thing. So I think usually what people do is they kind of just want to find what x is and what y is, and then you can substitute it in. A simpler way that I learned over these contests is that if you have these kind of variables, there's a way to manipulate them. So how do you rewrite x squared plus y squared? So if you kind of think about it, couldn't if you want the squares, couldn't you just like raise them to the power of 2? I know it is look like it's already raised to the power of 2, but what I'm saying is that why wouldn't we just have x plus y and then raise that to a power of 2, right? So if we factor them out, we have x squared, right? X times y, and then y times x, which is 2xy, right? Is plus y squared, right? So we have this thing, and you say that this, and you could say that this is not equivalent to this, right? So what we have is that this here and this here adds up to together is this, right? So technically, all we need to take out is this number. So if we're going to find this, we just have x plus y, right? And then we subtract 2xy to the other side. And then we get this number, because we only have these terms left, right? So technically, we already know these numbers. We don't have to look for it. We have x plus y, which is 9, so it's just 9 squared, minus 2x times y. We know x times y, which is 12. So 12 times 2 is 24. So it's just minus that 24. So 9 squared, which is 81, minus 24, which is going to be 57. So it's basically just that simple. Instead of solving for what x is and what y is, you should find out what if you do enough of these contests and you understand these patterns, or like you've seen these outside of class or in class, you're gonna see these patterns where you could just do things differently, and then based on what the information you're giving you just substitute those numbers in, and then you get the answer instead of like finding what x is and what y is, which takes a little too much time. So usually for contests, you like to like budget your time and like solve everything as quick as possible, but make sure you're accurate. If you don't know how to solve it, usually you just skip to the next question. But that's just my advice and how I usually take the contest. But if you have a different approach that works for you, just do that. So number 15 was answer was 57. So that would be the way you do it. Okay. So let's try number 16 now. Number 16 is what's the largest 5-digit number that's a multiple of 11 and does not use any digit twice? Okay, so we have x, 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 right? So that's 5 digits, and it's a multiple of 11. Okay, for this, it's gonna take too much time. If you're gonna, you could use your calculator and start spamming numbers, and you could start from like 99999 because that's the largest possible, right? And you want to get to the largest 5-digit that's a multiple of 11. So you kind of just like find out ways, kind of keep dividing this using your calculator, like keep going like different numbers, right? 9998. It's gonna take way too long, and we want to save time in the contest. So if you don't know the rule for 11, the way that you would do it is generally you're gonna have 9999, right? This number, 99,999, and you're gonna divide that by 11. I know it's not. So we know that this is not gonna come out as an integer. It's gonna be like 99,090.818181 repeating, right? So it's gonna keep doing that. So what you do is that you just gotta ignore the decimal, and you're gonna have 9090. So you're gonna have 9090, and then you're gonna have that all the way down to like the lowest number, which is not 9999, but 1100000, right? So 10000 divided by 11 is equal to 909, right? So you have these two numbers. So you're gonna have to be. So usually, since since they asked for the largest, you're gonna start with this number and go straight down. So you could be 90, and then 90, 89, then 90, 88, and then 90, 87, right? So you could just keep doing that until you find out a number where the digits are not used the same way. So it's just be 90 over 90 times 11, which is repeating 9 4 times, or 90, 89 times 11, which is repeating 9 4 times with the 7 now, and then 90, 88 times 11, which is 99968, so only repeats 9 3 times. So doing this will still take a while, but this will be the simpler solution instead of testing every single number. So, but if you know the divisibility rule, uh, which you should know, there's usually a lot of divisibility rules you could learn. It people say that you don't have to memorize for contests, but generally there's some things you just should understand. So, like divisibility rule for 1 is that basically everything's divisible by 1, so everything is divisible by 1. The divisibility rule for 2, it's just that the end term has to even, right? So it's like 23. This is not even, so it's not divisible by 2. You have 22, that's divisible by 2 because this is even. Now, if you have divisibility rule for 3, right? We have 23, right? Is this divisible by 3? Well, 3 plus 2 is 5. Is this divisible by 3? No, it's not. So this is not divisible by 3. And that's usually how you find out. If this is like, let's say 3, 1, actually, let's say 2, 1, 3. Is this divisible by 3? 2 plus 1 plus 3, which is going to be 6. 6 is divisible by 3, right? So this is divisible by 3, which is true because 21 divided by 3 is 7, divided by that is 71. So you have 71. So you know that's divisible by 3. So the divisibility rule for 3 is that the sum of the digits had to be 3. I'm not going to talk about every single divisibility rule. You can search it up on the internet. But basically, the divisibility rule for 11 is that each alternating difference, it basically has to add up to a multiple of 11, or it's going to add up to 0. So what I mean is that we have, let's take our case for a 5-digit number, right? So we have x, 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 x. So usually you're gonna have an even number. It's gonna have even digits. So we're gonna put a 0 in front, because you can't put a 0 in the end because then it's gonna be a 6-digit, right? So you put a 0 in front. Or if you have a 6-digit, you just have x x x x x x, and that's all you have to write. We just want evens, okay? So we want even amount of digits. So since we have 5, we need to add one more just to make even. So you usually just add it in front. So if it's odd, just add a 0 in front. If it's even, just leave it alone. So what you're gonna do is that you're gonna have this number subtract. Actually, let's, instead of writing the x's, let's actually write some other letters. We have 0, A, B, C, D, and E, right? So we have these two. So 0 minus A is just negative A, right? B minus C, and then let's actually kind of separate this. So this one gets negative A, B minus C, and then D minus E. Okay? So whatever you get for these numbers, right? You're gonna add them together. If this ends up as a multiple of 11, it could be like negative 11, negative 22, negative 33, or like 22, 11, 33, 55. It doesn't matter. It has to be a multiple of 11, or it's gonna be 0. Okay, so it's either one of them because 0 is divisible by 11. It doesn't seem like it, but it is. So 0 is going to be a multiple of 11. So any number that is like a multiple of 11, it's going to basically be divisible by 11. So you know that this number is going to be divisible by 11. So how do we know how this works? Well, how do we find out which one is the largest 5-digit number? Well, basically, we're just going to logic our way through this. So what is the largest 5-digit number we can have? We said this before, which was 99999, right? So the highest term is going to be 9. So we're going to assume that the first term is going to be 9. If it doesn't, we could just change the number to 8. So we could just make some assumptions first because we're looking for the largest possible. If it doesn't work, we're just going to use the next largest possible, right? So we're just going to do some trial and error. So A is going to be 9, right? So 0 minus 9 is negative 9, right? So from here, if you had to look for numbers, what I do is that instead of looking for a number that's like, if this gonna add up, the difference added up to 22 for the divisibility rule, basically you're just gonna look for numbers between the multiples of 11. So we have -9, right? That's between 0 and 11, right? Those two intervals. Because you're not going to choose, I mean, -11. You're not going to choose 0 and 11 because if you have 11, 11 plus that 9 is 20, right? So you have to move 20 distance away to get that answer is equal to 11. So it's going to take, it's impossible, right? So even if you have 9 and 0, which is 9, 9 and 0 is 9, that's 18. There's no way you could get to this 20. So the only possible numbers that you could get to from that 9 to make a multiple of 11 is that you gotta get to negative 11 or 0. Okay? So we're gonna focus on those possibilities first. So let's focus on negative 11 first, and then we're gonna focus on 0. So this is -9, right? So you're gonna have to get a -2. So what's the next number we have for B? So since we can't use the same digit twice, we could say this is 8, right? So if we want to have this, since we want this to be like a negative, right? Technically, it's not going to work because we have a 9 here, because that makes like negative. That makes that makes -1, but you're repeating 9 twice. So the next highest number we could have is 7, which is going to make 1, right? So if you have 1 here and you have -9 here, that just makes -8, which gets us a little gets us farther away from -11, right? Because we have to -3 now instead of -2. So we have 8 and 7, right? You don't have. It's not that the possibility is out. It's just that we're gonna try these as errors, right? So we have -9 for these two numbers. The difference between 8 and 7 is 1. So we had to have this as -3. So what's the highest possibility for this number? It's gonna be a difference of 3. Since the highest number is 6, we can have 6 here, and then we have 3 here. Can we have a higher number? Let's say that's 4, and that makes 7, right? Because you have to have a difference of 3. You have 7 repeated twice, so this doesn't work. So you can't increase this number any further. So the highest number for when you had to make -11 is 0, 9, 0.98736, right? So this is the highest possible number you can make if you're going to a multiple 11. So that's -11. Now, if we want to go to 0, we have 0.9, right? So that's -9. So if we want to get to 0, we have to add 9, right? So we have 8 here. We want the highest numbers, right? Because the highest number that you could get that where no digits repeat and it's a 5-digit is 98765, right? Because that's the highest digit and they're not repeating, and they're in the highest order. So technically, that's the highest. So we have 7 here, right? Let's do the same thing. That's 1. Now, what number? If we put a 6 here, right? The lowest number we could get is a 0, which makes 6, right? So, which we have these two numbers. We have 7, and that makes -2, which doesn't work. So we have to have an 8 here. So the only way would be like if this is 8 and 0, which we can't do because we already have an 8 here. So we know for sure that this cannot be a 7, because that makes it too impossible. So let's change this to a 6. Actually, let's not change this to a 6. Is sorry about that. This is still a 1, but instead of like choosing like 6 and 0, we choose numbers which could get to the 8. Actually, never mind. We could get to 8 and 0. So we can have 9, 8, 7, which is 1, and then we can have any numbers with 6 and 0 as the highest. So if we even choose any number higher than 0, it's just gonna make the number smaller. So this is the highest difference. So this one has to go down to a 6. Sorry about that. Now we have a 6. We have a difference of 2. Now we could use a 7 here. So 7 minus 0 is 7. So that's the highest difference we could have, which is also the highest number. So it's 2 plus 7 is 9, plus that minus that 9 is 0. So our highest number for this one is 98670. So this number is smaller than this number, right? Because you just look at it, the 7 is higher than the 6. So the highest possible, since these are the only two combinations, the highest possible 5-digit integer that's divisible by 11 and the digits not used twice is 098736. And that's basically just how you solve it. You just have to understand your divisibility rules, and then basically right, and then basically just use some logic and trial and error to find out what your answer is. Sorry if I couldn't pronounce that. It's like a tongue twister to me. So that's number 16. Number 17. The greatest common factor of two integers a and b is 24, and the product of a and b is 234,432. Okay, so the product of a and b, the greatest common factor is 24. So let's just factor out 24. 24 is just 2 to the power of 3 times 3, right? Because that's 8, and times 3 is 24. I'm going to write this twice, since let's say this is a and this is b, right? So since it has to be common fact, this is the greatest common factor, that means 24 has to be in both a and b. So what you do is that you need to find out numbers that are not 2 and 3. So we have 2, 3, 4, 4, 3, 2, right? So if you kind of have like, let's say x is the remaining amount of numbers in a, and y is the remaining amount of b, right? So if you're multiplying a and b, you get 2 to the power of 6 times 3 to the power of 2 times x times y, which is equal to this number, 2, 3, 4, 4, 3, 2, because that's the product of a and b. So 2, 3, 4, 4, 3, 2. And then you divide by 2 to the power of 3, divide by 2 to the power of 3, and then divide by that 3 and divide by that 3. So all you have left is 407, right? So x times y has to equal 407. Now, if you kind of factor 407, you get 11 and, sorry, the only numbers is 11 and 37, right? But like, let's kind of list out the combinations. Because 407, you can have 1, 407, or you can have the 11 and 37, right? It's not going to be 1 and 407, because they say determine the smallest possible difference. If you have 1 here or 407 here, or you can have vice versa, where it's just 1 here and 407. It kind of doesn't matter because these numbers are basically the same anyways. So the difference is going to be really big because 407 is so far away from 1. But if you choose something like 11 and 37, right? It doesn't matter which place you put it because they're the same, as I said before. It's a lot closer, so the difference is a lot less. So you kind of think about it, it's just 37 times 2 to the power of 3 times 3 is b, and 2 to the power of 3 times 11 is equal to a. So if you kind of have that out, that's 24 times 11, and 24 times 37. So the two numbers you get is 264, and this number is 888. So 888 minus 264, you get your answer as 624 as your smallest difference. And that's basically how you solve it. Pretty simple. You just have to write everything out. Number 18. 4 cards with the numbers 2, 3, 4, or 5 is written on them. No repeats are placed into a bag. So there's only 4 cards, and each of them, there's one of them is a 2, another is 3, another is 4, and another is 5. 3 cards are drawn from the bag one at a time without replacement to create a 3-digit number. How many? So you're taking out 3 cards basically, and you have to make a 3-digit number for that. How many multiples of 6s can be created? Okay, since it said it has to be a multiple of 6, that means the number has to be even. Since the only evens are 2, 3, 4, and 5, the only numbers are 2, 3, 4, and 5, the only evens are 2 and 4. So the units number has to be 2 and 4, right? So you have A, B, right? Doesn't matter. So these are the only possible. Now we just need to find out if it's going to be a multiple of 6. Okay, so a multiple of 6, the divisibility rule for a multiple of 6 is that it has to be, it's just need to pass the divisibility rule for 3 and 2, right? Because 3 times 2 is 6. So if it passes 2 and it passes 3, right? It's divisible by 3 and divisible by 2. It has to be divisible by 6. So divisibility rule for 2, I already said, is that unit digit has to be even. So, and to remind you, the divisibility rule for 3 is that digits have to add up to 3. So a plus b plus 2 has to be equal to a multiple of 3. So basically, what number is going to use instead of 2? We have 3, 4, and 5. So which one could plus that? Which two numbers plus that 2 could each equal a multiple of 3? So since all these numbers are, except for 2 is higher than 3, but it's got to be higher than 3 regardless. Let's just use 6, right? So can we make a 6 out of here? We have 4 and 2, right? So we could put a 4 here, and we could put a 3 here, right? So we have these numbers. We could have 4 and 3 because 4 plus 7, 4 plus 3 plus 2, that's equal to 9. 9 is divisible by 3, so it works. Can we have 3 and 5 together? That makes 8. 8 plus 2 is 10. That's not divisible by 3, so it doesn't work. 4 plus 5 is 9. 9 plus 2 is 11, which is not divisible by 2. So the only combination is 4, 3, and 2. So the only two numbers are 4, 3, 2, or 3, 4, 2. If we have the unit digits equal to 2. Now we have a unit digit of 4, right? So with the 4, what numbers can we use? Can we use 2 and 3? That makes 5, and that makes 9. That works. So 2, 3, 4, or 3, 2, 4, right? Now we could just have, can we use 2 and 5? That makes 7, plus the 4 is 11. That's not divisible by 3, so it doesn't work. 3 plus 5, that's 8. 8 plus 4 is 12. Okay, 12 is divisible by 3, so that works. So we have 3, 5, 4, and 5, 3, 4, right? So we have these combinations only. These are only ones. So 1, 2, 3, 4, 5, 6. So you have 6 combinations. So the answer for number 18 is 6. It's basically just that simple. Okay, number 18. Number 19. A 24 feet by 40 feet hallway is tied by 1 feet by 1 feet square tiles. Two opposite corners of the hallways are connected by a line segment. Exactly how many tiles does this segment pass through? If a segment passes exactly through the intersection of 4 tiles, so it kind of looks like this. So it kind of looks like if it passed through like right here, through the intersection of 4 tiles, the segment is considered to have passed through 2 of the tiles. So it doesn't pass through all 4; it's gonna pass like 2. So let's say it's these 2 or something, you know. So okay, so that's your general idea. So we have a 24 by 40 hallway. So we have something like this, 24 by 40, and each tile is 1 by 1. Okay, so it's just gotta be 1 by 1. So think about it as a unit. So we're gonna have a line. And we just need to find how many tiles like it kind of goes through, basically, right? That's not drawn to scale. I'm just trying to draw the outline. So generally is that, how do we do that? Because technically it's not going to go through every single one perfectly. Like, what you do is that, since you know you have a 40 and a 24, you kind of see where the pattern like goes in. Usually when you look for geometry, it's kind of just patterns. So what we have is we have 40 and 24. Could we break this down? We could, because generally, if you kind of think about it, if you divide both numbers by 8, 24 divided by 8 is 3, right? And 40 divided by 8 is 5. And if you kind of think about it, you have a line that goes through here, right? And if you keep going, right? If you keep going, we could just have another box, and that makes a 3 plus this 3 is 6. This 5 plus this 5, I'm sorry it doesn't scale, but basically it does. Both the rectangles are the same size. And that would be equal to 5. Okay, right? So this would be 5 plus 5 is 10. So if you kind of think about it, what we have is that we have 24 and 40, right? So instead of focusing on all these entire, like, squares in between, let's just focus on a small part and then scale it up. Because basically it's just going to look like this, right? Sorry, my drawing is kind of bad. But, so something like that, you know? So, I didn't draw it to scale, and the math is probably going to be wrong, and the rectangles don't look the same, but the because the picture is just basically bad. But basically, this is the general idea. So we could just focus on one thing, but since it repeats several times, right, we just scale it up by that amount. So basically, all we have to do is that we divide this. We just need to find that scale. The scale is 8 because it's just 24 divided by 8 and 40 divided by 8, right? So you just look for the greatest common factor. So we have a 3 and we have a 5, right? So divide 24 by 8 is 3, divide by 40, divide by 8 is 5. So we have something like this. So we have a 3, 1, 2, 3, and 5. So this is also not going to be the big picture. So that's something like this, right? And we have a line that goes through like something like that. Oops. Trying my very best to do this. Okay, we'll do something like this. So technically, if we look at the 3 and 5, we just had to find out how many we could go. Since we scaled it by 8, that means that must be there's 8 more of these to go. So we just had to multiply by 8. So all we had to do is just look for this one. So we have how many tiles does this line go through? It goes through this one. It goes through this one. It also goes through this one. Well, how do I know? It's just that the drawing is bad. But basically, we have 5 to 3, right? That's our slope. So if this is 5 to 3, that means right here, it's just 5. This length is just 5 to 3. Because this is, if you kind of think about it, this is just 1, 1, and 1. And this is 5. So if you only went to 1/3 of the length for this triangle versus this triangle, that means this is just 5 divided by 3. So this entire length is 5 over 3. But this entire like rectangle, right, is a 2. So 5 over 3 is less than 2. So it has to go through, it has to be below this point. So what that tells me is that it goes through this rectangle, and this rectangle. And it has to go through this one. Now you kind of see the picture. It goes through this one. And now we just need to find out if it goes through this one, because technically our picture is just bad. So what we have is we do the same method since it's this triangle versus the entire triangle. So that's 5 over 3. So since this is 2/3 of the entire thing, that's 10 over 3, which is just 3 and 1/3. So that's why I said my drawing is bad, because it's 1, 2, and 3. So 3 and 1/3 is like right here. So but I like made up to 4 because my drawing is just bad. So technically, it goes through this thing also, and it also goes through this one. So let me erase that part. So it goes through this one, it goes through this one, right? So what the line should have looked like is that it should look like 1/3, and then 1, 2, 3, 3 right here, and then goes like this. So you kind of go through this one, this one, this one, this one, this one, this one, and this one, right? So what's the total of that? That's 1, 2, 3, 4, 5, 6, 7. CS 7. Now, we also have to consider, since they wrote in the parentheses, if a segment passes through the intersection of 4, since it passes through this one, right, there's another one right here, another one right here, another one right here, right? So it goes through the intersection of those 4. Technically, we don't have to do anything, because if you think about it, since it's going to be repeating, like right here, this thing is the same thing as this entire thing. We're gonna be counting this, which is gonna be this one, which is your scale up. So we're already counting 2. We're not counting this and this. So all we had to do is that we just had to scale. So we don't have to consider it. So it's just 7, and since we scaled it by 8, we just multiply 8. So 7 times 8 is 14, 28, 56. So your answer is just 56. The answer for number 9 is just 19 is just 56. All you technically had to do was just scale. Okay. So that's an interesting geometry question. Now, let's go to number 20. Okay, the long answer. If a completely fictional survey of 40 people, in a completely fictional survey of 40 people, 30 people said they like only the Cubs, 8 said they only like the Cubs, Sox, and Bears. The number of people who like only the Cubs and the Sox was more than the people who like Cubs. Okay, so there's 3. There's Cubs, Sox, and Bears. Before I finish reading that, let's actually kind of label. So we have a Venn diagram. So we have a Cubs, Sox, and Bears. Cubs, Sox, and Bears, right? And there's 40 people in here plus the outside in case there's any. And they said 3 people only like the Cubs. Okay, so there's 3. 8 people like all 3, the Cubs, Sox, and Bears. So 8 people is inside. Okay, the number of people who like only the Cubs and Sox, so right here, is 1 more than the number of people who like only the Sox. So, and here. I mean, sorry, it's right here. Cubs and Sox was 1 more than the number of people like the Sox. So if X people like the Sox, that means 1 more like the Cubs and the Sox, which is just right here, which is X plus 1. And the number of people who only like the Cubs and Bears, which is this side, is 2 less than the number of people who like the Bears. So why people like the Bears than 2 people from here. There's 2 less people that likes the Cubs and the Bears, right? And they said the difference between the number of people who liked only the Bears, which is y, okay, and then it says difference, so we minus, and the number of people who only like the Sox, so minus x is equal to 7. So the difference between the number of people who like only the Bears and the number of people that like the Sox is equal to 7. If the number of people that like the Sox and Bears, which is this thing, is minimized, so we want to find the min of this, right? How many people like the Cubs and the Sox? So Cubs and Sox. We want to look for this thing right here. So all we have to technically do is find a minimal value. So we know that the entire thing is 40, and they said everyone at least. So I forgot the sentence. Everyone liked at least one of the 3 teams. So there's no people outside. So all in all these circles together, it adds up to 40. Okay. So we have y plus y minus 2, which is 2y. And then we have x plus x plus those 2x. And then I'm just putting the variables together. If you add them up together a different way, it's gonna be the same result anyways. So you have a negative 2, that from that 3, that makes 1. So 1 plus 1 is 2, plus the 8 is 10, right? And that entire thing is equal to 40. Oh yeah, and I forgot the min value. Let's just label this as C. We'll call that C. Okay. So let's kind of move this up. I'm just going to do the math here. So sorry that I don't... Actually, let's just delete the entire thing. So we already have the math. So if you want to like have the picture written down somewhere, you could, because I don't have the room for it. So we have 2x plus 2y plus 10 plus z is equal to 40, right? That's what we got. And they were given us that x minus y is equal to 7. And they said they want z to be minimized. So if we sum and subtract them together, we have 2x plus 2y plus z is equal to 30. Now, if we kind of just have this side, multiply this side by 2, so this gets 2, 2, and this gets to 14, right? So you add them together, that's 4x, the negative 2y plus the 2y is 0, so plus the z, so 30 plus 14 is 44. Since we know that 44 is divisible by 4, that means z has to be like a 4 multiple. Because then a 4 multiple right here minus the 4 multiple divided by 4 multiple would just get you an integer, right? Because you can't have z is equal to 1 because this is going to be even plus odd is going to be odd. But this is even, so it doesn't work. And you can't have 2 because then that would be like 42 divided by 4. It doesn't work, right? So it's just going to be a multiple of 4 generally. So the least common multiple 4 is 4, right? Because you can't... They said everyone liked at least one of the 3 teams, right? So everyone liked at least one. So if the number of people that like the Sox and Bears is minimized, which is 4, then technically 44 minus 4 is 40, and then 40 divided by 4 is x is equal to 10. Since we were looking for the number of people that like the Cubs and Sox, which is just one more than the people that like the one more than the people that only like the Sox. X is the number of people we like the Sox, so it's just plus 1. We get our sorry. Do I write this wrong? Oh, sorry about that. I wrote the equation wrong. We have... Sorry, it was y minus x is equal to 7. Same concept, it's just minusing x this time. So multiply by 2, so that's 2y minus 2x is equal to 14. Add that to that, so you have 4y plus z is equal to that's 30, so that's 44. Okay, so z is going to be 4, same concept, so y is going to be 10 this time. 10 this time. So technically, since y is 10, you can substitute it back in here. So x has to be equal to 3. So the number of people is just one more than that, so it's just plus that is 4. So just keep track of where your equations are. I'm sorry that like it's why we're adding one and you don't understand right now. But if you're keeping track of all your equations and you have that picture that I just wrote before, you understand like which variables go where and which you're looking for. So the answer for number 20 is just 4. And that basically covers everything for the CCML, right? For the CCML Algebra 1, Contest 1, 2017-2018 Division A. Thanks for watching, and I'll see you at the next math record.